organize the work yourself. There's no manager telling you what to do. You do that yourself as an agile team.
First thing is the test should be based on requirements and design. We could also talk about design, but today we talk about requirements. And the question is now, what should the tester know about requirements and why is this important? What I will do is, in this talk, in the main part, I will talk about on a very high level, so just really to give you some inspirations about the framework of requirements engineering, which part of this is also the backbone of the certified requirements engineering certification from IREP. And I will focus on things which are maybe not so easy to grab, and if you are interested in more details, you can read in some books further about this and acquire the knowledge accordingly. Then I will talk a little bit about model-based documentation of requirements, just 2 slides, mainly to get across that modeling is much better than textual specification, also holds for tests. And then a little bit about goal and scenario, and why goals and scenario are important for requirements engineering and why they are also important for testing. And then of course some up a little bit. So this framework of requirements engineering has 3 core parts in the center. The first one is based on a paper I wrote a long time ago, I think it was 92 or 93. The 3-dimension of requirements engineering, and at that time there have been very controversial discussion about this. If this is really a thing which characterizes the goals of requirements engineering. The first dimension is what we call content dimension, and it deals with the content requirement specification has, so which requirements are defined and at which level of detail are requirements defined. The second one, there already the disagreement, at least at that time started, is the documentation. And in principle, it's important to see documentation orthogonal to the content, because in requirements engineering, you want to define the requirements in a way that the stakeholders which need to understand them, which need to validate them, are able to understand them. And therefore, essentially, documentation has to be seen as orthogonal to the content. One of my favorite examples, also quite a long time back, I got a set specification, so a formal specification for a system, 30-something pages, and the company wanted that we do a validation of this set specification. After 1 hour, I sent it back and said, this is crap. The whole specification is totally crap. I listed 5 or 6 key things which you see immediately, and there were at least another 100. And they said, this is impossible. This set specification of our system was validated by 4 different validation groups, including all kinds of stakeholders, the user, the customer, the manager, and all these kind of things. And they showed me the bond policy. It was true. They had 3 meetings where this specification was validated, and nobody detected any problem. You know why? There were only 2 people who were aware about formal specification. So all the other people looked at the thing and said, yeah, I believe, oh, this looks really exhausting, this looks difficult. They must have had a good knowledge, so I believe in it. So therefore, documentation really depends on the goal you have. We will come to this for the model-based documentation later on. And therefore, it's really important in requirements engineering that you differentiate between content, so what you have understood and what you know, and the way you document it, and later on specify it. And the third one, quite obvious nowadays, at that stage, at least in computer science, not so obvious, was the agreement dimension. And this is simply because typically there isn't an agreement out there about requirements. People have to agree in the process about requirements. And I personally think for testing it would be good if the tester also have knowledge about where have been problems. So where was the disagreement about a requirement, how has this been resolved, and is this agreement still true when they define the test cases? Just one simple example. So these are the 3 dimensions: content, the thing you have understood, documentation, the way you have documented and later on specified it, and agreement, the agreement you have reached between the different stakeholders, which is maybe not the easiest part. This builds a cube, and a typical process, a very idealized one, somewhere starts at the bottom with individual views, with a very vague understanding, with informal documentation, and ideally it ends with a complete understanding, complete in two ways, namely in terms of all requirements identified and specified at the required level of detail. And also a consolidated view, that means an agreement between the stakeholders. So you can have the best requirement specification that you can build, but if people disagree, it's worth nothing. And you really have to reach all three of them. And from this you essentially get three key goals of requirements engineering, which is to identify requirement sources and elicit the relevant requirements in the required level of detail. I think there was a tutorial on Monday about the elicitation, if I'm not wrong. Chris, was that? Yeah? So if you want to have knowledge about this, look at the material for Monday from Chris about elicitation. Then you have to document and specify the requirements in compliance with the format you have agreed on. And the formats, the documentation formats, like text or models, depend on the usage of these formats. And you have to establish a sufficient agreement, which means you need to identify conflicts, you have to resolve conflicts, and wherever possible, you have to make, at the end, trade-off decisions. And if you believe this, then it's very easy. Then there are three core activities in requirements engineering, namely documentation, elicitation, and negotiation. And this is nowadays also in the literature, I think, very, very common, sometimes with different names, but that these three activities coexist. They are not executed like a waterfall model. They are executed very, very iteratively, and when you look at the documentation and also in processes in industry, there's always one of this dimension which is a little bit neglected. So if you check, for example, if you divide test cases, if you check if there are conflicts have been identified, if there is really an agreement about the requirements, sometimes you may detect that the documentation says nothing about this. And then, at least it makes sense before testing to sort out this problem. Even more, it would be a very good idea if the requirements engineer, like in the agile approaches, like in Scrum, is included from the beginning, all phases, and also the tester, and they take care that the requirements are documented, for example, in a way that the test cases can be derived more easily and more systematically than, for example, just with text. So first part, three core activities. Second part, one part, system context, and also a thing, at least in the projects we work in industry, heavily neglected. I try to get across the key idea between the system context, and there are really two essential things, easy to remember, often neglected. The first thing is the separation between system and system context. So the red line somehow is the border between the system and the system context. The system, of course, interacts with its context. And in the context, you can have documents, standards, processes, people, other systems, whatever you can think of, immaterial goods, material goods, all kinds of things, where the system has some kind of relation with. Like the user of the system is a typical one, but also the infrastructure the system is running on is another one. And the very simple differentiation, which in industry people really often struggle with, and again, which is important for the test, is the rule is very simple. Things inside the system boundary can be changed, and things outside the boundary cannot be changed. So things outside the boundary are given, so they are predefined, and you have to accept them when you develop the system. Things inside the boundary can be changed and can be adapted according to the design of the system. This holds not only for software and hardware, this holds also for business processes and things like this. If a business process is inside, you can change. If it's outside, it's given, and you have to design the system in a way that it satisfies this process. So it's very important what you put in your design space and what you put out of your design space. We did this about 6-7 years ago. Not since then. We checked industrial specifications if they define clearly the system boundaries. None of them does. And as a tester, what do you test? You test the thing inside the boundary if at explicit systems test if they have to write interactions with the things outside the boundary. You make much more detailed tests if the business process is inside the system boundary, compared with the system when this process is outside the system boundary. So even for test case derivation, I think this separation has an influence, and you should be able to understand this. We will see this in a little bit more detail in the next